the Unicode properties are wrong. They're not all wrong, but there is a pretty large number of exceptions and overrides that you have to do on what Unicode defines, because they just got it wrong when they defined it, and they want to keep backwards compatibility. The biggest problem, and the reason why we still all depend on half-bars, and it's difficult to replace it, is not really because the programming is difficult, but it is because nobody knows what to do. Because when the specification is wrong, what becomes the real specification is just whatever DirectWrite decides to do. There are some fonts that are still widely in use that were created for Windows 3.1.
What?
And they are called the Windows 3.1 Legacy Arabic fonts, and Halfbuzz has a special case for them.
First, tell me about your background, programming background. How did you get into all this?
Yeah, I mean, funnily enough, I started programming pretty late. I had a lot of time as a kid to do basically whatever I wanted. I had very good grades, and my philosophy was always, just take care of the schoolwork as quickly as possible, and then just spend all of my free time on video games, right? And I was
playing or making?
Yeah, playing video games, and so I did a lot of that for a while. And when I was 10, I got my first actual PC that I could use to do whatever I wanted. And very quickly I got into competitive games. And
Nice.
at the time it started off with Team Fortress 2, which I've played for I still play it now, but I basically only did that in my free time for a long time. And after that, a few years after, one of my friends was like, hey, let's buy Counter-Strike and let's become really good at it. No specific reason, right? But at that point in my life, I already understood something kind of fundamental about myself, which is that I just find the process of, plunging into something new and really discovering everything and learning how these systems work and trying to use them to my advantage to really just be incredibly rewarding. And so that means I got really good at games, right? And I was really interested in getting good at games. And I think at the time it was also easier for me there was more reward in it for me to spend a lot of time in getting good at games rather than studies, which were they didn't really go anywhere. It was really easy for me. So I was like, okay, I'll play Counter-Strike if you buy me the game, because I'm a kid, I don't have money, right? So he did, and we played it. And 6 months later, I was Global Elite, which was the highest rank you can get on the official ladder.
6 months?
Yeah. Apparently that's not common, but I basically only did that in my free time, right? That was my life at that point.
Okay.
And I was, I think I was, end of middle school and start of high school. And so I was trying to figure out what I wanted to do with my life. And I was like, okay, well, this competition thing seems to be working out pretty well. I'll just keep going in that direction and see where it leads, right?
Let me interject here for a moment. What you are referring to as Wookash Podcast is having its own private Discord server where members and guests of the show can chat together. On top of that, members can know in advance who's gonna be on the show and can submit questions beforehand. Go to wookashpodcast.com to learn more.
So I found a bunch of cool guys who were willing to play with me, and we formed a team and we played in a few tournaments. We had some mixed successes, but a couple of us in the team were actually quite good, and it ended up basically that When I was 17, I talked to a few teams in France who were actually like semi-pro level. And they were like, yeah, we're not going to hire you. We don't even screen if you're below 18 years old, right? Like, not interested. Just like, come back next year. And, you know, when you're 17, a year is a long time, right? I didn't want to wait for an entire year. So I was like, screw it. I'm going to do something else now. So, yeah. So I was like, you know, I like this. I like these computers, right? And I'm pretty intelligent, and I think I can figure out how to program games, because that's also something that I wanted to do, and one of the avenues that I imagined I would go on at some point. I even made the joke at one point when we were playing a lot of TF2, like, oh, what are you going to do in your future? And I'm like, I'm just going to be like the TF2 engineer, right? Just working at Valve and making fun stuff. So luckily I had, there was a special class in my high school that was just created that same year, which was about computer programming. And since it was a teacher-driven effort, the two teachers that founded the class were actually really interested in, you know, teaching computing. And I think it was, you know, we ended up doing some Python and just like a really free-form project. I ended up making a chess engine, which was fun. But I think the lesson that stuck out to me the most at that point is, before doing any programming at all, they had these exercises where you just learned the basics of like Boolean logic and like, you know, just a basic like Venn diagram. And it's like, okay, this is A and this is B. And like, we're going to give you Boolean expressions, and you're going to have to fill out the blanks and say which is true and which is false. And I think it really talked to me, because in a lot of ways, even now in my programming style, I'm very like, just integers are packs of bits, and everything is just packs of bits, and so I just see the bits everywhere, right? And so that's what really made me want to go further in that direction. So high school went pretty well, and afterwards I went to university, thinking I would do more freeform or like creative problem-solving kinds of stuff that I did in high school programming. And we basically did none of that. Yeah, I mean, we just had however many classes of, I'm going to teach you the basic syntax of Python. This is a variable, and this is how you declare a function. And, you know, and just that over and over again all the time.
And this was computer science degree.
Yeah, it was computer science. Although there was at the time there was a weird drive from universities to stop being theoretical and to teach more like practical, professional stuff. So actually, the classes I got were a lot less computer science-y and a lot more like technician, like just a low-level Python script guy who can do a bit of like simple stuff on the computer sometimes, right? And I wanted none of it. Like, I was like, this is not programming. This is not at all what I did, you know, last year that I loved. And furthermore, I don't want to do this for 3 years. But I mean, in France, you kind of have to. Like, if you don't have a degree, you just don't have a job ever. So I was really angry for a while. And I think at the end of the first semester of my studies, I encountered Handmade Hero, you know, and the rest is history, as they say. I just chose to focus Handmade Hero exactly the same way I did with competitive games, where I was like, this is my laser focus now. I'm just going all in on this, right? As soon as I'm out of the classroom, I just go home and I watch Handmade Hero and I do everything. So I just watched like the first 50 episodes or something. And then I went back and coded along because I didn't know anything about C and I wanted, a bit of an overview before I began.
Okay. Can you tell me, because Handmade Hero came out in 2014, right? When did you encounter it for the first time?
Handmade Hero was out way before I started universities because I'm from 1999. I'm 26. So I got to university when I was like 17, so it must have been 2016 or something.
Okay, couple of years after it came out. Okay.
Yeah, there was a couple years worth of episodes to go through. Really.
Oh yeah.
Yeah.
Oh yeah. Okay. So I think the story repeats across a couple of episodes here that the actual drive for programming, like the passion for programming, is happening alongside Handmade Hero, like rediscovering the joy or discovering for the first time happens with Handmade Hero. What in this series was so, I don't know, striking, or like why it was more engaging than other things that you've done during university?
Well, I think I'm just very binary in my life choices a lot of times, and sometimes I just look at something and I know I don't even want to try to do it because I know I'll hate it. And sometimes I just see something and I'm like, okay, this is what I want to do, and I'll just do it. And so your comment reminded me that when I was like 14 or 15 or something, I did actually try to go and learn programming, but so I went on the most popular French educational technical site at the time, and they just taught you like, oh, just go download code blocks and create like a player object and like an enemy object and just have like the method that's like dot attack, and then at the end, so you wrote like 100 lines of code, and at the end all you did was just print something. And I was like, I'm not gonna do that. Like, who wants to print something? And who wants to write like 100 lines of code? Like, I think at the time I already kind of figured that most of the code in volume did nothing, and that it was just like wasteful. And so I didn't really want to, I didn't really trust that source of information anymore. So I just stopped, right? Which is completely opposite with Handmade Hero, where, the first thing you do is you open a window, and to me it was kind of magical. Like, windows were always kind of like an opaque black box to me, where like, oh, it's a magical thing that appears when you open a program, and it's like, no, actually, like you can create your own windows, and also you can like modify them and decide what goes on the window and what doesn't, and you have a lot of control over that. And it was just really fun to really go behind the scenes on that, which, yeah, I think that's, the Handmade Hero experience, right? For people who aren't used to it.
Yeah. This is super interesting. Like, on the one hand, this is Casey Muratori sits in front of the computer and streams like coding, and you can say that, like, you can make a case that this would be the most boring thing you can encounter as a learning resource, right? Like, because it's just one person doing his work and pretty much that's it. And then on the other hand, you have so many courses prepared exactly so that you are, optimizing gamified experience to reward you and do like sort of wow when you program. And so many times, like, this Handmade Hero series wins over these courses and the effect of this series on starting up a generation of programmers that are willing to go such a long way to do something that is difficult. It's just mind-blowing to me, honestly.
Yeah, no kidding. I mean, I don't think learning is boring, honestly. And Handmade Hero is, you say it's boring because it's just somebody typing on the computer, but really, like, when you're not used to the entire process of programming, like something that's big, right? I mean, at least 10,000 lines or something. There's just so much to unpack in anything Casey does, right? And one of the ways that I really like to learn stuff is just learning through osmosis, where I just plunge right into the thing that I'm trying to learn, as if I knew what I was doing, and I just listen to people talk about it. And I don't want to be talked to like a beginner, right? I just want to listen to like the high level conversations and try to decipher them bit by bit. And for me, Handmade Hero was obviously Casey spends a lot of time explaining what he does, but that's not really how you learn. I mean, that's not how I learned on Handmade Hero. It was more like trying to code alongside and debug my own things. Oh, so that's why the other thing doesn't work. And so basically just pretending I'm a game programmer, right? And writing my own thing.
Yeah.
So
yeah,
for me, the model works just fine.
Yeah. Just to be clear, I don't find Casey boring. Quite the opposite. Like, I think Handmade Hero is fascinating, and I got through the same experience of doing a couple of episodes at some point, just dropping and learning so much from them. It's just that if you take this from like business value proposition, you would think that like this free resource available on YouTube would be way lower than this handcrafted course that somebody like tried to optimize, and it's sort of is the opposite, at least from what I can see.
I mean, from my own experience, I never used anything else to learn programming. I just did Handmade Hero for basically the full 5 years of my programming degree, like engineering degree, which is a weird thing in France, but it's just a master's. It's 5 years. So I just did Handmade Hero during that time outside of my studies, and I was so far ahead of anything we learned. And after getting my bachelor's degree, I actually went to like what was supposed to be a really good public school for computer engineering. And one of the last tests we had to do was write like a basic OS. So they just gave you a harness that did the BIOS initialization and threw you into like a main sort of function. And then you had to initialize like the memory map for the x86, and you had to create like a process layer and launch a few processes and have them communicate through virtual memory, right? Like interesting stuff. And all I learned from that course was just the specific APIs you had to use to make that work. But like the fundamentals you already really learned with Handmade Hero when you coded the arena, right? Where you're like, oh, okay, so you do virtual alloc, and like, oh, how does virtual alloc work? Well, it works like that, and so I don't know. It just makes everything so much simpler when you focus on really the fundamental knowledge, the deep knowledge that applies to anything, rather than just like the superficial. Oh, I need to poke this register, and so on that test. That test was supposed to last 2 hours, and like just writing basic Handmade Hero style code, I was done in 15 minutes and got a perfect score, right? Like, I don't know. Handmade Hero just works.
Awesome. Okay. So you encounter Handmade Hero, you start following along, and during your university, you keep going and you learn from Handmade Hero mostly. How do we get from there to text rendering?
um, well, at the end of my studies, I had to do an internship, and I was I actually had two studios or two internships that were proposed to me, and one was with the studio that worked on Microsoft Flight Simulator, which apparently is still programmed in France, which I did not know. And the other was like a 5-person company that did weird things I didn't really know about. So I interviewed with the Microsoft Flight Sim guys first, and before you have the interview and before you can even submit your resume, you had to do a programming test. And the programming test was like just inane questions over and over. Like you had a linked list where it was like pointed to prev and pointed to next, and then a single integer, right? And there was like a 5-line function that did like a mathematical operation on the nodes, and there was just a comment at the top that says optimize this, and they wanted you to do like a mathematical optimization, like actually figure out like, okay, what are they computing and how can I compute it faster. And I did that, but above the code I actually wrote like a huge comment that says, this is stupid anyway, because like we're doing like 3 arithmetic ops per node. Like obviously this is not even going to mask like loading the next nodes because it's a linked list. So it's going to be slow. Like you need to mask the load with arithmetic ops because you can't really prefetch because it's all serially dependent. And so it's just you just end up being sad. Like I modified the code, it does fewer ops, but it's not going to be faster. And I did that for like a couple of their questions. And so a few weeks later, some technical managers, something or other, messaged me and I was like, hey, can we talk on Skype? And I mentioned the test and I was like, have you seen the responses I had on your test? And I was like, no, I don't even look at the answers. And I was like, okay, well, if this is how you're going to respect my code, my work, like I don't want to work for you, really. So I'm just good. Like whatever the other guys are doing, I don't know what they're doing, but I'm gonna do that instead, right?
Wow. Okay. So you didn't end up working on flight sim?
No, I did not. Maybe if you actually work for them, it's cool. I just really did not like, I just felt disrespected, really. Because I spent like an hour commenting this stuff and like showing that I knew something and trying to convey something, and it just went into the trash, right?
Yeah. Yeah. So what the other people were doing then, the 5-person company?
Yeah, so I still work at that company. It is an EDA company, which is Electronic Design Automation, which is basically like all of the tools that help you create circuits and circuit layouts and wafers and wafer layouts from your design that you do in like Verilog or VHDL or whatever else. I didn't really know anything about electronic design, and I still don't, because we don't really work with the designers. We work downstream from that. We work more on the process side of stuff, and the process is all like, okay, we don't design the CPU, but just like how do we create the masks and how do we create the wafers without half of them just like burning, right?
Yeah. Okay.
So, in practice, what that means for you as a programmer is you have the layout for a CPU, and, if it's the layout for a modern CPU, it's going to be freaking billions of rectangles or something, and you have to do arithmetic or geometric operations on those rectangles. So you end up with a lot of overlap with the HPC, the high performance computing category of problems. So there's actually a lot of interesting stuff you can do there. Just like massively parallelize everything and work on huge sets of data. Like we have files that are terabytes big sometimes, and you just have to make it work.
Okay. If you were to categorize a little bit HPC problems, this would be it. Massively parallelized things, algorithms to run on GPU, something to give more context.
Mm-hmm. Well, HPC, I haven't, I'm not really in that community very much outside of work, so I don't really know how they would describe it. But the way I see it is basically, you have, unlike games, you have a very high throughput requirement, but you don't have any latency requirements.
Yeah.
Like, you don't need to finish a computation by the end of the frame or anything. You just have a huge batch of operations to do, and you need to do them as quickly as possible. But you can take as long as you want, quote unquote, batching things together, and you just need the result at the end. However soon that comes, right?
Okay. All right. So this does not relate in any way to text rendering and text in digital space at all, right?
It does not. So the way my history goes with this company, which shall remain unnamed for this interview, is that the interview went like we talked a bit about my GitHub because they actually went and read my code, which is already a good sign, right? So we talked a bit about my GitHub, and they were like, "Oh, you do SIMD stuff?" And I was like, "Yes, SIMD is interesting. I do it sometimes when it makes sense." And they were like, "Okay." And pretty quickly we realized, I could do whatever they needed me to do. So I had a 6-month internship with them, and during the first couple or 3 months, I had my internship subject to finish. So yeah, spoilers, I finished it before the 6 months, but it was actually a really interesting problem, which was, we have these tools that have to do some geometric operations like oversizing polygons and rectangles and downsizing them, and trying to preserve some, compute some, not really assertions, but design houses have this thing that they call the DRC, or the design rule manual, and the design rule check, which is that you have these constraints that you have to check for everywhere in the circuit, right? So again, we go back to these HPC kind of problems. So they had the functional tool that produced a correct result, but it took like hours or days or weeks, depending on the size of the circuit, because it just did the basic naive thing, right? It didn't really have any sort of acceleration structure. And so that's where I was asked to actually work for the internship, which is like, okay, here you go, here's the tool, just make it as fast as you can and document the results, and that's going to be the internship. And that was great. I loved that because you really you can really just go all out in HPC with like gratuitous, like, let's build these huge data structures and let's take all the time we want at setup and then just blast through everything, right? So I did this R tree, which is just like a hierarchical tree made up of smaller rectangles, so that you can do hierarchical queries and you don't have to check everything all the time. So I built that, but I built it in such a way that the whole construction of the tree was branchless, and it was trivially parallelizable for very large sets of geometry.
How was this branchless?
Well, radix sort is a thing. So
Okay.
yeah, the way I did it at the time was you have a whole bunch of geometry, and each piece of geometry has a bounding box. And so you take all of those bounding boxes and you assign them a number, nebulous description of a number, that will tell them where they go in the final sorted array. And that means that, there might be some collisions, but then you just have buckets. And what it means is that you can compute all of the numbers in parallel, and then you just need a way to, have the order make sense. So how do you have like an order make sense in a 2D spatial structure? Well, there's a class of mathematical objects, I guess, that exists for that, and it's called the space fitting curves. So you have a z-order curve that's just like builds z's, and then just larger z's, and it goes like this hierarchically. So that gives you some idea of where the rectangles are on the circuit. And we also had a second higher quality mode which used Hilbert curves, but which was also slower to evaluate. So that's why there were two modes. But yeah, so once each rectangle is mapped to a number, then you can just do a radix sort, which is, you pre-allocate the buckets, or you just split the arrays where it makes sense for the space fitting curve to be split, and then you just partition that, and at the end you either do a merge sort or you just flatten everything into a single array, depending on how complex your dataset is.
Okay. That sounds awesome. That sounds like an awesome problem to work with, and also a super cool internship, because you get something that is not tied to all the other things that companies working on, and so you don't need like dependencies. You're not depending on every other person in the company, so you have something separate, also very well defined. You have a scope, and you just like go away, do your thing. It's fine. It's awesome. This is your playground. This sounds really cool.
Yeah. It was my playground for like 3 months. Yeah. And I mean, I went all out where like you had an iterator for your query that worked with 0 copy, so you never had any memory throughput or memory traffic. You could just work directly on the pages for the geometry, and like, yeah, it was really cool. Unfortunately, that was the by far the most technical thing I've ever done for this job. So I had a great time for the 3 months, and then the rest of the internship was spent writing the report, basically. And I mean, the issues that I have right now with the company did not really show in the internship at all, specifically because the subject was so cool. But really now it's a lot more like, hey, I thought of a really cool way to enhance this tool, and we can go like 100 times faster and do this, or like we can parallelize this. And most of the time I just get turned down, where it's like, no, it's too complicated, we can't do that. And it kind of reminds me of like the interview you did with Anton, which is like, oh, hey, no, but we can actually do this, and it's not that complicated. And systematically the response is like, no, we can't. And anyway, even if you did it, it would be a waste of time, and nobody would care if it was 100 times faster. And I'm like, I don't agree.
Okay.
But also I'm not CEO, so I don't get to make the decisions.
Right. So how I am still, in this mode of finding the link from your work to the text stuff that we want to reach. How does it happen?
I mean, you have almost all of the pieces right now. What happened is I got kind of fed up with the work I was doing for the company. And so, I mean, I still work for them, and I still do, my duty over there, no problem. But my mental energy is really spent on my own projects. So I'm part of a composition community, music composition on Discord, and I ended up making a video game for them, and that video game was used an existing framework. And I was like, okay, this is cool, but like now I want to rewrite it in C and see how much of that framework, which I actually thought was pretty cool, I can integrate or I can implement simply with my own code. And turns out I could implement a lot, and basically everything was taken care of except for text.
Okay.
And that's how I decided, okay, well, I really don't want to use half bars. Like it would be the only library that requires like separate compilation, or like that requires bringing in C++ things where you only use C. And also it's like huge. It's like 10 times bigger than my project. And so I don't want it. I don't want it. So at that point I was like, well, how hard can it be to just replace half bars? Right?
How hard can it be? I love this. I think I've heard this so many times where people were describing the project. It's like always a great adventure lies ahead when you say, how hard can it be?
How hard can it be indeed? I think another motivating factor was that anytime I went on the internet to see like people talk about text, either rendering or shaping, they were like, no, you can't re-implement that yourself. It's too hard. Like no one person can do all of that. Never mind the fact that half-bars was made mostly by one guy, right? Like you can't do it. It's impossible. So, yeah, again, I kind of wanted to prove those people wrong as well. But yeah, I had no idea what I was getting into really when I started the project.
Okay. So maybe we can take the time now to sort of describe what needs to happen for the text to appear, and then what you wanted to build.
Yeah, of course. Well, first of all, we need to define what text is, and what it is for the purposes of this, this talk is, in the Unicode world, text is a stream or a sequence of what they call code points. And what is a code point? Well, it's basically just a really fancy term for like a unique integer they assign to what they consider to be like a character or like a piece of information, basically, in the stream. Those code points are 21-bit large, and the definition of a code point does not really say how they are represented in memory. Yeah, it's really just like, you can think of it as like almost a mathematical or like an algorithmic description of the thing, which is like, we're just talking symbolically about these numbers. So what happens in practice is that you need to represent them in memory, right? So that's where the text encoding comes in. So your text is not just Unicode text, it's going to be like UTF-8 text. And what is UTF-8? Well, it's the scheme by which you translate the code point into a series of bytes. And so UTF-8 is actually an interesting way to encode those bytes, because the way it works is that for each byte in the stream, some amount of bits in the byte are going to go straight into the code point, and the remainder are for control purposes. So the remainder of the bits are going to tell you, okay, how many bytes are there left in the code point? And that also allows you to know, am I in the middle of the code point? Am I at the end, or am I at the beginning? So there are some nice properties there that make it practical to use UTF-8. But you can just go like really stupid and say, okay, well, the code point is 21 bits. We'll just round that to 32. So just widen the 21 bits to 32 and just say, okay, so this is my 32-bit integer and it has 21 useful bits, but it's fine, right? And so that's UTF-32. And UTF-816 is just, it's also variable sized, just like UTF-8, but it works with shorts, which are just like 16 bits in size.
Okay. When you say code point is 21-bit, but it doesn't say anything about memory layout, I have trouble to wrap my head around it.
Well, if you have a given text that is in Unicode, quote unquote, you don't really know what the corresponding memory should look like. Chances are it's UTF-8, and so you can, everybody can find their way around the text if it's UTF-8. But with UTF-16, for example, it wasn't clear whether, the most significant byte was in front or behind. And so you had to have a byte order mark. And so there's basically, like, depending on your text encoding scheme, there's a layer of craft that you have to deal with to actually decode the code points.
Okay.
But you can make up any text encoding scheme, really. Like, it's just a mathematical function almost, right? Most of them are really simple, and nothing's stopping you from making a new one.
Okay. With UTF-32 being almost like the most dumb version of just adding the bits that are remaining to wrap to 32, and then you're like, off you go. Okay. So this is text encoding. So we have properly expressed code points in memory with an encoding that we can read.
Exactly. So all that I explained here is basically just to say, if your text is in UTF-8, you're going to want to decode it into code points anyway, because all of the Unicode stuff works in code points. So there's just one more step, which is decode your buffer from whatever the encoding is into actual code points. And you don't have to do it, as an entire block. You can do it in a streaming fashion, but the step exists for sure.
Okay.
Now, really old school font systems were really simple, where it was just, usually it was just ASCII fonts, but you also had, specialized language fonts that worked with code pages or like specific sets of code points that were predetermined. And so what's the simplest way of rendering text? Where it's just, you have a table that goes directly from one code point to a glyph, which is a visible thing that's contained in the font. So you have your code point that's directly mapped to a glyph bitmap, and then the bitmap says how big it is, and it also says how much to advance the cursor by when you draw it. Right, that is like super old school. Anybody can work with this, it's fine. At some point, we realized that was not enough because resolutions were getting bigger, and so we needed to be able to scale the text. And so the way we did that is basically just replacing the bitmaps with descriptions of the outline of each glyph. And those descriptions...
Okay. I'm just opening my mouth because I actually understand it. This is not me trying to say something.
No problem. Feel free to butt in at any time, right? And those descriptions, those outlines, are made of like Bezier curves, which are just a very simple way of representing like a quadratic curve, which was the first model. There's also other types of encodings which use cubic curves, which are a bit more accurate and have more degrees of freedom. But basically, you just have a pile of curves, and we just say, okay, so the way you determine if a pixel should be filled in or not from the curves is you cast a ray, so you draw a line from the very left to the very right, for example. Could be top to bottom or anything, but usually it's left to right. And you say, you count the number of curves that you've crossed. Okay?
Yeah.
If that number is odd, then we are inside of the glyph. And if that number is even, then we are outside and we don't fill in the pixel. Right? That is the very basic algorithm of glyph rasterization.
Okay.
So that model is the TrueType model, actually. So when you see like a TrueType font, which is a surprisingly old type of font, it basically means that, you know, it was at the time when we started replacing like hard-coded bitmap tables into glyph outlines. Now, something fancy you could do with, say, English, but like the Latin script, for example, is, say I have a T and then an O, right? Or like even like capital T and then O. If I just follow along what I said, and I was like, okay, so this is how much the T requires to advance, and then so I'm just going to put the O here. Well, I have this T, and the O is here, and they're super far apart, right? So that's done. I mean, it looks stupid. It looks unprofessional, at least. And you really want them to be closer together because, you know, as the font designer, you know that the O is not going to intersect with the top bar of the T, right? So the way we solved this issue, again, was the most simple way possible, and is just to have like an n-squared table for your glyphs, which is like, if this is my first glyph, and this is my second glyph, and then next together, then you just offset the x position of the cursor by this much. And that's it. And that gives you what we call kerning in the typographic world. It's exactly this. It's just making sure that all of the glyphs are properly packed when they should be.
This is... How big are these tables now? If you have a lot of glyphs for languages, it must be massive.
That's a trick question because you said now.
Yeah.
We don't really use these tables for modern fonts now. But you know, you can imagine at the time, you know, it was like 2000 or something. Most of the fonts were really like local to one script. And so typically you could get away with like 100 glyphs per font, maybe more.
Okay.
And so the n-squared wasn't actually that big. But I mean, you're right to ask for that because if you're trying to render Chinese or Japanese, well, there's thousands of characters, right? Turns out they don't really need kerning, so it's not a problem for them. But they do, you know, they do still need to store a lot more fonts or a lot more glyphs per font, obviously.
Yeah. Okay.
Okay, so that was the TrueType model. Again, just making this very clear, no half bars yet, no need for half bars yet. This works great if you're trying to render what we call a simple script. What simple scripts are is, you know, if you look at the Latin alphabet, you can see that all of the characters are just kind of boxy and kind of regular in size. Obviously, not every font is monospaced, but most of the characters were made and kind of evolved with the printing press. And so they were made with this kind of creation and consumption in mind, which is like very simple to lay out for a machine and very simple to duplicate and so on. So Latin actually lends itself very well to this kind of simple solution. Greek does too, Cyrillic, and the Asian languages I've mentioned, so like Chinese and Japanese and Korean also, are pretty easy to translate into that model. So that was fine. But now what if you want to render Arabic? Well, it gets a bit more complicated because what Arabic is a cursive script. Excuse me. And, we can also write cursive with our alphabet, of course. And when we write cursive, our hand makes sure that the different letters join together to make a contiguous line, right? And there's no mechanism to really make sure that this happens in the stupid fonts that are basically printing press-like. So that's problem number one. Problem number two is Arabic is a contextual script in the sense that one single letter in Arabic does not have a single visible representation. One single letter in Arabic is going to look like one thing if it's the first letter of a word, it's going to look like something else if it's in the middle, and it's going to look like something else entirely if it's at the end. And so this is also why I mentioned earlier that Unicode code points are kind of like the ideal symbolic representation of characters. The code points make no effort to make it easy on the computer to handle text. What I mean by that is that you could imagine a text encoding in which the first letter of the word is a different code point from the middle of the word form of the same letter, which is a different code point from the last letter in the word, right? You could imagine a world where this is true, but it is not. So it falls back to the downstream algorithms to figure out what we have to do. And so this is basically how text shaping came about. The way this was solved, or solved is a generous term, but the way this was solved is by having open type fonts, which are still based off of true type formats for most things, but they add rules that are contextual, so they kind of like pattern matches. You can imagine they're like kind of like a very simplified version of regular expressions. So they add these rules that say, okay, so if you see this pattern, then change the second glyph of the pattern into this other glyph. Or like if you see, for example, if you see a minus sign and then a greater sign, then replace those two separate glyphs with a single arrow glyph because I have a ligature programming font and I'm trying to be fancy, right? This is exactly the kind of problem that OpenType tables were meant to solve, right?
So the OpenType is a font.
Yeah, it's an extension of the TrueType format.
Okay.
So just for reference, like the glyph outlines are described exactly the same as TrueType. The rendering algorithm is the same. You can reuse it just fine. The only thing they've added that is really crucial to rendering these languages are the what they call the G-sub, so glyph substitution, and G-pos, which is glyph positioning tables, which contain these rules.
Okay.
So that's the ideal or idealistic description of the problem. Ideally, what you would do as a programmer is just implement these fonts and be done, and everything works. Turns out the rules are not powerful enough to do what they wanted. So depending on the script you're trying to shape, you have a bunch of hand-coded passes that you have to do on the text at very specific points in the pipeline to say, okay, so for example, in Arabic, before applying any rules, I go through each glyph and I say, okay, does this look like it is the first word the first letter in a word. If so, then I tag it to be modified by the rule later on in the font that is supposed to apply only to glyphs at the beginning of a word. And I just do the same for every other letter type. So that most of these passes are not that complicated. I mean, it's just buffer management. The problem with them is that, unlike the gsub and gpos algorithms, they are basically, as far as I know, completely undocumented.
What?
Yeah, so officially, on Microsoft's website, you have the OpenType specification, and they have a section that's like advice or guide for developing fonts for whatever script, and that is where they describe their algorithm, where you have the hand-coded passes and the order in which to apply the rules. And I don't know when those were written. Supposedly, they described direct write functionality at some point, which direct write is just the text engine for Microsoft. Supposedly, they described something real at some point, but that is clearly not the case, and it hasn't been for at least 10 years. So everything you see on that website basically is wrong. Yeah.
Okay. So let's say the specification that would be for the OpenType, at least from the Microsoft angle, so for the Windows products and stuff like that, for Microsoft products, is outdated to the point that it's not usable.
Yes. And the specification kind of belongs to Microsoft. Microsoft are the publishers of the specification. There have been efforts from the text community at some point to write new documentation, which you can find on GitHub, actually. It's you can just look up OpenType shaping documents, and an attempt was made, and it describes some things correctly, but it gets enough things wrong that I'm not even sure that I gained any time by reading it.
Okay. So it's a mess. There is no correct source of information for OpenType.
Yeah, so the biggest problem and the reason why we still all depend on Halfbuzz, and it's difficult to replace it, is not really because the programming is difficult, but it is because nobody knows what to do. Because when the specification is wrong, what becomes the real specification is just whatever direct write decides to do. So the way Halfbuzz has been developed, and, bless the Halfbuzz developers, because they were the ones who my work is based on, so kudos to them. So what the Halfbuzz developers did is just copy direct write. And you don't have the source code to direct write. So it's just fully black box reverse engineering. You just throw text in and you look at the output, and then you just figure out, okay, why is this different from my result? And you do that as long as something is wrong, and when everything works, you can hope that maybe you find a solution.
How much of this type of work, how much percentage of your work was this type of guessing, trying things out and updating your source code compared to like a normal style programming?
Oh, it was a lot. If I just look at the volume of code I can output and modify when I don't have to reverse engineer, like the first 10,000 lines were written in the first 3 weekends or something. And then 90 to 95% of the time was just spent debugging, okay, what if I insert this glyph here? Well, Halfbuzz does something completely different, and why is this script different from this script when they're the same page on the Microsoft website? I don't understand. And most of the work has gone into that, for sure.
Okay. So Um, are we done with the technical background of text processing? Because I want to make sure that we wrap this and then we zoom in on the story of the development of your library. We talked about TrueType and font rendering, then OpenType, how this modified the shaping, and we also mentioned text encoding. Is there something you should add?
We are almost done.
Okay.
There's just one step left.
Yes.
So the one thing to remember is you can't just throw any string to a shaper, because what happens if you throw in a string that is like half English and half Arabic, right? Well, the way it works is that your sentence is going to start left to right, and then for the Arabic portion, the cursor will jump all the way to the right of the Arabic word, because Arabic is right to left. And the text is in logical order, not in visual order. So you go left to right while it's English, and then you jump to the right, and then you go right to left while it's Arabic, and then you re-jump at the end of the word and continue left to right for the rest of the English sentence. Right? That is how bidirectional text works. And this jump is important because the rules in the font are encoded with adjacency in mind, right? So it's just like if you see these two glyphs next to one another, you replace them with a single glyph. But in this case, well, the glyphs are next to one another in the stream, but they're not next to one another visually. It just doesn't work. It can't work. So you cannot give a bidirectional string to a shaper. That is the first issue. The second issue is that the rules you will want to apply to the text will depend on the writing system. And so anytime the writing system changes, you need to change the rules, and so you need to start a new string. Right? Those are the two like really minimal examples of what you have to do to get proper shaping. And so you need to split your input text into what we call runs, but they're basically just substrings of the text, right? Runs which have a uniform direction and uniform writing system. And that step comes just before shaping, and it's called text segmentation. And once you have that, you have all of the pipeline.
Okay.
So you're good.
Okay. So if I can summarize this, we start with... Okay, the other way. We start with encoding, right?
Yep.
We know what we want to do. Now we split this into runs during the segmentation. We do the shaping, so we actually understand what shape each glyph should take up on the screen, and then we do the rendering.
Yeah.
All right. Awesome. Okay. And okay. Then, if we move towards your work, you decided to write your own library from scratch in C to answer the problems of shaping and segmentation, right?
Yes. At first it was just shaping, but then I realized I tried to use my library when just shaping was implemented. I tried to integrate it into Casey Muratori's RefTerm, which is a terminal renderer. So I tried to replace Uniscribe, the Uniscribe code, which has a block comment that's like, this is super stupid, Uniscribe sucks, we need to replace this. So I replaced Uniscribe with my library, and I was like, oh, this doesn't work. This doesn't actually do anything meaningful. And like, why does it not work? And it's like, okay, well, if you look at RefTerm, it actually handles the text somewhat intelligently, where it tries to find boundaries where you can think of the the bit of text between the boundaries as a single visual element that you want to put in a terminal cell. And so Unicode actually has a description for this, and it's called a grapheme. And RefTerm uses the grapheme segmentation alongside script and direction and whatever else. And so I was like, well, I could just find some segmentation library online, but there's it all seems kind of bad. And I'm sure it's not that big of a deal. I can just write it myself, and then it'll be integrated into the library, and it makes a lot of sense because like both want to talk about Unicode properties and scripts, and so it's nice if they can both talk the same language.
Okay.
This is how hard can it be, number 2, by the way.
Yes. Yeah, of course. Of course. How then? Okay, you started this sort of half because of the curiosity, half because you wanted to avoid half pass, right?
Yeah. I also wanted, like, as a personal goal, I also wanted to see how far I could bring like the full like C STB style. I'm going to write one file libraries for everything, and see how far I can get with just that and nothing else. So that was also, but yeah, basically that.
So walk me through the story of development. How did it happen? You mentioned already that like the beginnings were fast, and then the experimentation happened, and finding out corners, edge problems, stuff like that. So how did it look like?
Yeah, I mean the edge problems are more really like face problems sometimes. Like it's not just on the edge, it's basically everything is a problem sometimes. Yeah, so the beginning was fast because the OpenType format, like the file format, not what the shaper is supposed to do, but the file format itself is actually well documented by Microsoft. So kudos to them. There were a couple times where I thought their documentation was wrong, but then I went back and read it very carefully, and I was like, oh, okay, I didn't pay attention. But I have found very few issues with the file format in and of itself. So parsing it was pretty easy. One of the annoying things about OpenType is that it is a big endian format. So you need to byte swap everything that you load. And I thought it would be annoying and kind of slow. So when I open the font, I want to byte swap everything in the font. And so I can just write native code, like native C code, that just looks like normal C code afterwards, and just assume everything is in the correct byte order. That took a bit of time because OpenType actually contains a lot of offsets into things, which are basically just like relative pointers. So like, okay, this is the start of the table, and this table points to another table. And so we'll encode the other table as an offset, a byte offset, into the file from the start of the first table. Okay? And the problem with this is that there is a lot of table reuse, actually. So you can't just follow the pointers and byte swap things one by one, because you'll end up byte swapping the same table like 50 times and you have a 50-50 chance of being wrong.
Yeah.
So you need to do a smart thing there where you just I just record all of the base pointers of the structures that I byte swap, and if I see that I've already byte swapped it, then I just don't. But yeah, parsing the file was pretty easy, and applying the rules also was pretty easy to test. So like not much problem there. That was by far the fastest part of the whole thing. the issue came with complex scripts, where, so first off, you need to kind of figure out what the hand-coded passes really do. And secondly, you need to, so the hand-coded passes use something that I mentioned earlier, which is Unicode properties. And this is also the case for segmentation, where if you go read the algorithm descriptions, they're like, okay, so to know when the script changes, you're going to need the writing system property of the code point. And I went like, what the heck is that, right? It's just an integer, it's not a struct. There's no writing system enum anywhere, so like, how do I find that? And the answer is, you need to parse huge like CSV tables that Unicode calls the Unicode character database, which is just a very fancy way of describing where it's just a folder with CSV files in it. And so these tables contain like, okay, so for this code point, the writing system is this, and you need to parse everything and generate your own tables that you can use at runtime for this. It's important to note that this is not necessarily needed, or like you did not necessarily need to have tables for all of these properties if the text format was specified differently. Like Unicode just does this because it's very disorderly. But for example, if you're parsing ASCII text and you want to know if something is a digit, you're not going to have a table with a flag that says digit or not. You're going to do, okay, is it greater than or equal to the letter or the character 0? And is it less than or equal to the character 9? And I think a lot of people take this for granted, when really, like, this is just because the designers of ASCII did a very good job. And when you start working with Unicode text, you realize none of the nice, easy things that you can do on ASCII text work for Unicode. So obviously they have a table for like, what is a digit?
Okay.
So yeah, in order to, so that was the first big detour, really, which is before you can even get to programming the shaping passes, you need to parse these tables, make sure your parsing and your generation is correct, which is kind of hard to do when you don't have any code to test with them. And then you can start working on the algorithm and trying to see if you can replicate some of Half-Buzz's behavior. Now, the problem with this is that the Unicode properties are wrong. They're not all wrong, but there is a pretty large number of exceptions and overrides that you have to do on what Unicode defines, because they just got it wrong when they defined it, and they want to keep backwards compatibility. So I try not to read too much Half-Buzz code, and in fact, most of my reading was spent on the GitHub issues and not on the code. But what I did end up reading was some of their files for the exceptions to the Unicode properties per character. And also, Microsoft has exceptions that they give you also on GitHub, which is like, oh, okay, so if you want your thing to work like direct write, you need to parse this and replace everything we define in your Unicode tables, because Unicode's wrong, and this is how this is supposed to work.
Okay. So you like implementing what you have in Unicode is not enough. You need to gather the exceptions from various providers that they have for their stuff to work. Okay.
Yeah, this is Lord of the Rings, where everybody needs to assemble into a great like party of adventurers. Like you need the half bars overrides and the direct write overrides and the tables and so you need to merge those, for sure.
Okay.
I spent a lot of time trying to debug my logic when the logic was not wrong and it was just this character is just the wrong character class.
Okay. This doesn't sound like a fun thing to work on, to be honest. When we're getting to these exceptions laid on top of exceptions and stuff like that, because in the beginning you mentioned that the work looked nice, like you parse a format, you learn about how this format looks like open type file. Okay, you do like byte swapping. It's like a nice thing to do, and then you reach the end of the nice parts, and then like here are the list of exceptions, and then I can't imagine how much time you must have spent before you realized that you were missing some of the exceptions that you didn't know about, because you don't have a link from where you're at to an external list of exceptions in direct write.
Yeah, I mean, thankfully the first thing I did was just to go download Halfbuzz's test suite and transcribe it over to my code so that I could run it and see what they had put and just like show the differences between mine and theirs. And also, thankfully, there's a mechanism in Halfbuzz for like automatically dumping or like easily dumping the Halfbuzz buffer at different points. And so that was, because I didn't want to read too much code from Halfbuzz, so that was basically the poor man's step debugging, which is like, okay, so before this pass it looks like this, and after this pass it looks like this. And okay, so I have a test where they do a thing and I don't. And I also have a test name, which funnily enough is super important, because then I can just go on the GitHub issues and type the test name into the GitHub issues search bar and see, is there any patch where they actually added the exception, or they modified some of the code and added the exception into one of the passes. And it turns out for a decent number of the tests that's what happened. Yeah. It's just the Halfbuzz guys wrote the simple thing first, and then they found a case where they had a discrepancy with direct write, and so they reverse engineered it, and now I'm reverse engineering their thing.
Exactly.
Yeah.
The cycle goes on, the circle of life.
Well, hopefully I'll document the way shaping really works at some point. That's one of my goals, so to break the cycle, but it's difficult because there's a lot. I'm not sure I can even start writing it now because I might still be wrong about some things.
Yeah. So we're talking about your development. Initially started off from the file format and easier work than exceptions, a little bit more internet archaeology work and stuff like that. You mentioned a couple of times that you didn't want to read Halfbuzz code. Was it because you didn't like it? Was there some issues with licenses, or why?
I mean, Halfbuzz is like old MIT licensed, but I didn't want it. Like, I basically wanted to reduce the amount of trouble I could potentially be in as much as possible. And when I looked into STB Vorbis, which is Sean Barrett's Vorbis decoding library, he actually has like a chat log where he asks one of his friends to be like, okay, run this with the libvorbis, the official libvorbis, and like tell me, is the output more like this or more like that? And so he did this black box reverse engineering, and I was like, oh, that's probably a good idea if I don't want to get in trouble. Regardless of the Halfbuzz author's intentions to protect their copyright or anything, I kind of wanted this to be like safe.
Okay. So on the story of development, what happens next?
Man, I mean, really, most of the time was spent implementing the specific passes. I mean, I think one of the most interesting parts of OpenType is actually how it handles index scripts. So I can talk about that a bit. The way index scripts work is that...
What is it? What is it?
Yes, sorry. So the index scripts are just like the writing systems for all of the languages in the Indian area. So different parts of India speak different languages, but the writing systems actually have a lot in common. And so there are a lot of rules that overlap. So the way index scripts work is that the visual unit is a syllable. It's not a letter. It's not like a singular complex character like Chinese. It's a syllable with different parts, but all of the parts are welded together. Okay? And what's interesting about this is because Unicode is an unstructured format, and for some reason we've decided to use like unstructured, just like dumb stream formats for all of our text all the time. When we read the Unicode for an Indic language, we have no idea where the syllables are, where the syllable boundaries are.
Okay.
So there's a great amount of like just shuffling with character classes. So like, oh, the consonant must go before the vowel, and the marks go at the end, and then we can just assume that the font encodes its rules to work like this, and hope that it gets it right. And at some point, I was like, this would be so much easier with a structured text format. So the way you would handle Indic scripts if you were writing like a simple text representation for it is basically just there is a syllable base, which most of the time is a consonant, but sometimes it's a vowel. So there's a base, and then you can have an attachment to the right or to the left or above or below, and some of those attachments can also have marks, which some of them are called halons and other are just like normal marks. And so you can imagine having like a very simple struct that's like, okay, like freaking struct syllable, and you have like, here's the code point for the base, and here's the code point for the above part, and here's the code point for the below part. So I tried that. I actually tried parsing the Unicode form into structs, and being a bit smarter than the specification, where I was like, oh, okay, so for the tables that are meant to apply to the above form, I'm just going to forward them directly to the above part on my struct. And it almost worked. The problem is that the rules really are arbitrary. And so, and that's not the fault of the designers, really. They just pack however much design they can into the format. They don't decide the format. But the rules are arbitrary, so I found fonts that wanted to have like fancy ligatures or like replace consonants, replace entire syllables or entire parts of syllables, and that didn't work with a direct approach. But yeah, it actually taught me a lot about like, if you really want to narrow down the problem, it can become much easier than this. Like, this is going from ASCII to Unicode is like going from like the well-designed, well-constrained problem to like, we want to support everything forever all the time. And this a huge leap in complexity. And it would just be really nice to have something in the middle, but we don't. So that's what we have to work with.
Okay. If you were to change things in Unicode with your experience now and lessons you've learned, what would it be?
I mean, I think there are two solutions or two alternatives that I could think of. One of them being like go full on like structured, like have a struct that's like, okay, if you have an accented letter, here's the base, here's the accent, done. If you have a cedilla, you have a field for the cedilla, done. And then you just find a way to compress that so that the file sizes stay reasonable. But I mean, if you look at the actual memory and storage usage for a lot of applications, text is really not a problem, right? So I don't think the compression effort would need to be that heroic for it to work. But you would need to have like a protocol that says, okay, so now we change the struct type, because indic does want to be handled very differently from Latin letters. So that would be the first thing. Another alternative I could think of would be to keep the stream idea of just like one code point after another and nothing else, but then just have much more markers, like structure markers inside of the text that says, hey, by the way, I'm starting an index syllable here, and hey, by the way, I'm ending the index syllable here, and also, hey, by the way, like the thing after myself is an accent that is supposed to attach to the thing before me. And I mean, I think you could go pretty far with this without fundamentally changing a lot of the algorithms. It would just be like a lot less work to try to find out what to do in the first place.
Okay. This would be like, now it would be backwards incompatible, right? If it was to be added now, because you would have additional things in the stream. Okay. So wrapping up the story of your library, you eventually got to the like 100% of the test cases from Harvbus. When did you decide to release the library?
I did not get to 100% because some parts of Harvbus are exceptions that I don't need to handle. So when I mentioned earlier that I bundled segmentation alongside shaping, one thing that my segmenter does is when you're reading Arabic, which goes right to left, and then you're reading a digit, like a number, the numbers still go left to right, and then you start right to left again. So that's a classic bidirectional text example. Right, so the way Harvbus handles it is they have a fallback case where it's like, if the user sent us Arabic text with digits in it, then we flip the digits.
Okay.
And there's a bunch of features like that, which are like, let's just work around people's mistakes with text shaping and segmentation that I don't handle because I control both sides of the pipeline. So I can be like, yeah, this doesn't work because why don't you use my segmenter? It's in the same library. Like it's just two function calls, right?
Yeah.
So we save a lot of, well, I don't know how much code that ends up being, but we save a bunch of legacy mechanisms with this. I also don't support crazy fonts like Windows. So this is fun. I learned that on the Arabic internet, there are some fonts that are still widely in use that were created for Windows 3.1.
What?
And they are called the Windows 3.1 Legacy Arabic fonts, and Halfbuzz has a special case for them. And, that provides some utility to some users. And I was like, I'm just going to support like modern OpenType fonts, and that's it, basically. So those are the two main things that I don't implement. The third one is just like very unspecified scripts. So I know I said OpenType is not specified or it's wrong, but there are some scripts that are so unspecified that like there's basically only one font that uses them, and it's internal to the Android OS or something. And so I was like, I'm not going to implement this either because, yeah.
Okay.
But it exists, like it's in the Halfbuzz codebase, and I do fail that test, right?
Yeah. How big is the library in terms of lines of code?
Oh, the lines of code written is 12K, and the final size of the library as it was released, the 1.0 was like around 22K. But like the 10K difference is just the tables I mentioned earlier.
Yeah. Okay. And maybe we can talk a little bit about the release and the reception of the library. How did it happen?
Yeah, I think I definitely think the reception was way bigger than I ever expected. The thing is, the 1.0 version of the library is kind of lousy. Like, it does what you want, it does shape text, but the API is not that good because it was just the simplest way for me to get started with something functional. So there are some stupid holes in the API that some very patient people have been communicating to me. And so I learned a bunch, and I'm now in the process of drafting a V2 API that will supposedly last a long time. Like, it can actually be stable for years, no problem. So, I mean, certainly I was super stoked to see that people were interested in my work, right? Thankfully, when you release a library, not everybody jumps on it instantly, so I don't have hundreds of people that I'll bother with the V2, and the V2 should come out pretty soon, I hope. But yeah, I think a lot of people are just interested in divorcing themselves from really like huge libraries, and especially finding new ways to avoid the bad APIs that we've just learned to work with, because there's no alternative, really. And I don't know, whenever you start working on a project and you're in your own code with your own APIs, it's just like programming joy, right? Like, you're in the flow and you know the APIs and they all make sense, at least for your use case. And when you use an STB-lib, it's also incredibly simple to use. And whenever you have to use like a very retained mode black box API, like Direct Write and Halfbuzz, which are just like, oh, instantiate this buffer and send it some commands, and maybe it does something sometimes. And I mean, again, to the credits of the Halfbuzz devs, their library works, right? It does what you want, but it does it in a way that strips control away from you. And this kind of a reaction I get when I don't feel in control of things that happen in my program, where I just get a bit anxious. And I think a lot of people kind of feel this more or less strongly, and that's one of the reasons why people were really, really excited to see a new Halfbuzz alternative that actually tried to focus on API design that was a bit more STB-like.
Yeah. Shout out to Sean Barrett and the design of single header file libraries, which KB text shape follows, because I don't think we ever mentioned your name of the library, KB text shape, throughout the discussion.
Yep, that's the name. Yeah, Sean's advice on writing small programs in C, which is a video you can see on YouTube, is one of my favorite programming videos of all time. Like, it has taught me so much about just like, okay, here's how you do actually productive things, and here's how to actually like achieve code reuse for C projects. And I mean, I just write everything as a single file now.
Oh, okay. Nice.
I mean, KB text shape is a single file, obviously. The test harness is just test.c, and the thing that generates all the code in the tables is just build.c, and that's it. And I don't even try anymore. It's just single file.
You don't even try? Meaning what?
I mean, I don't even try to structure the code or to have some kind of like project organization if it doesn't really make sense. So there are two modes. There's like, okay, can I isolate this piece of the system into something reusable? Yes, make it a single file library. No, just put it in main.c. That's it.
Okay. Do you have any problems when the file grows too long? Like 20k lines of code in one file. Do you have any problems with editor or stuff like that?
I mean, not yet, but I don't use VS Code.
Okay.
And I say that obviously as playful banter, but I actually used to use VS Code for a while, and I stopped using it because it was a stuttery mess on larger files and larger code bases.
What do you use?
Well, I used Vim for a long time, and then at some point I just tried more standard text editors, and I just measured the time it took for me to, so like you record yourself doing programming, and you see where you lose time and where your programming flow gets interrupted, because it's very hard to realize when it happens when you're really in the thing, when you're doing the thing. So like what you do is you record and you time how long it takes you to do X or Y. And I have found that basically just a simple text editor with multi-cursor is significantly faster for me than Vim.
Okay. So simple text editor with multi-cursor, meaning Sublime or Notepad++, assuming you're on Windows, or?
I didn't know Notepad++ had multi-cursor, but yeah, I use Sublime.
Okay. I don't know what it does. I know that it has a ton of plugins, so might be. But I'm not sure.
Yeah, I'm not a plugin person.
Okay.
The less configuration I have, the better I am, really.
Okay. Do you use debugger?
Yeah, of course. Actually, it's funny because I have a Linux machine, and when I write portable code, I have a setup where I can compile code as Windows executables, and I run them through Wine because then I can use the Windows debuggers.
Okay. Nice. Do you use Rad debugger?
Not yet. I still use Remedy, although I plan on learning Rad at some point.
Okay. So I'm guessing you're not really using AI for code generation. So you don't strike me as a person that would do, but...
Well, my comment on control may have hinted you towards that, I think. I think it's a very personal thing, right? I just like feeling like I'm in control of everything, and being able to jump to very low levels and very high level systems, and feeling like I know my way around the code, which I I've never used AI, but I feel like maybe I would lose if I did. And there's another very, very personal thing that I feel is I don't want to talk to a machine. Like, the whole point of us having machines is that we don't have to talk to them and have to coordinate with them. We just tell them what to do and they do the thing. And we have invented a pretty good way of telling machines what to do, and it's called programming, right? And I don't want to go back to just talking to a machine and pretend it's a human. Like, it just feels wrong to me to just have a human seeming interface into a program, and also have the program pretend like it's a human. Like, oh, you're right, I was wrong, and like I don't even want to hear it. I just want the result, right? So yeah, I haven't seen. I mean, there's also the thing that, I'm working on projects that nobody else really does. It would have been pretty difficult, I think, to make AI work for text shaping, because there's just so little information, and what little information there is on the internet has been proven to be wrong. So
Yeah.
I don't want the AI spitting back to me things that are wrong, right?
Yeah. You might be in a very difficult case for AI usefulness with your actual case of text shaping, because if you have all the standards and information that are wrong, and like, how often will the AI get anything right if you really get only the issues and errors?
Yeah, that reminds me also. Sorry, just like a quick tangent.
Yeah, of course.
Typically, when I played in competitive games, I tended to play like the more like flexible / support role, where it's like, okay, I'm not going to be like mechanically the best, but I'm going to find like ways to make myself the most useful, really, like just to win. And I think my approach towards going into text shaping was also this, where it's like, okay, look, I'm only 26. I haven't released anything, personal that has been used by other people. I want to get experience. At the same time, that means I can't just release something that everybody else is making. I need to find like a niche, something nobody else does, to really make what I do useful. And so I also think there was like a lot of strategy of programming in this project, where it was like, okay, how do I make my time also just like generally useful, right?
So how did you find text shaping to be the problem that fits your criteria?
Well, just that nobody else does it, so there's no competition really. I mean, it's a stupid thing, but you can. I'm not doing text rendering because lots of people are doing text rendering, and lots of people are good at text rendering, and I don't think I have anything to add there. I don't think I have anything new to bring to the table on text rendering yet. Whereas if I see, like, if I can imagine in my head, like, the V2 API that I drafted, and I can see how the pieces fit together, and I'm like, okay, so this is a useful piece of software that nobody has done, and specifically the niche is ease of integration and good API design. And I really like, so again, I just try to focus on that because I think that's where I can make the most impact, really, for the effort I'm putting in.
How would you help other people find these kind of problems that they could spend time work on?
I think this dovetails nicely into like a more general problem, which is, platform holders used to make useful tools for developers, and now everything's kind of been Apple-ified, and everybody wants to have full control over who gets to run what executables, and you can't just download anything on the internet. And so it's just become more and more antagonistic. But at the same time, there are tools and libraries that the platform holders provide that we don't have any alternatives to as like a programming community, right? So text shaping was definitely one. Like, we did not have any way to shape text without, direct write if you're on Windows, core text if you're on Mac, and half bars if you're on anything like a console, right? And I think this class of use case, this class of tools, we should be working on anyway, because like, we don't really want to depend on platform holders anymore. Like, it's become very clearly and increasingly so kind of a toxic, abusive relationship between Microsoft and the Windows developers who just want to make good programs. And I think that's also why, Ryan, who was on the podcast here before, has mentioned that he wants to make a Linux version of his debugger, which is, at the end of the day, I think the only tools we'll be able to use long-term, like, if I want to use a debugger and I know I will still have it in 10 years, I'm not going to download Visual Studio. And so it's kind of up to us to build up these systems in a way that fits our way of work and that we can reuse and retarget and use stably for years.
Yeah. We mentioned before the show when we were talking the regulatory capture that is very visible while working on the text shaping library. Do you have anything more to add? How this was visible throughout the work and how it affect you in general?
Yeah, I mean, so just very quick, regulatory capture, for those who don't know, is, there is technically an open type specification, and regardless of the fact that it's wrong, like, imagine if it was correct. The way regulatory capture works is just that the system is so complicated and full of legacy craft that nobody can just come along and try to re-implement it. So either by obfuscation, by having an incorrect specification, or just by sheer complexity of like, oh, you should handle 1,000 different image formats for this model thing, because like maybe the texture is in the format that hasn't been used since the 90s, but we still put it in the specification, and so you have to support it. And I mean, I think unfortunately someone has to bite the bullet. I think it's been very beneficial for me to work alone on KB Text Shape, just because I just ended up very often having like 50 tabs open in my browser, which is just like 50 different GitHub issues, and doing the crazy thing with the from The Office, where you just have like the yarn.
The map, yeah.
And I think this is the kind of like very complex intertwined system that you should really just be like one expert to untangle. It doesn't mean you have to be alone to do everything. Like, obviously, the RAD debugger, Ryan's working more on the debugger application and interface. And there were other RAD people who worked more on the PDB reverse engineering. But yeah, this is basically like, the person who starts working on the PDB format automatically becomes an expert, and you really want to give them space and time to deepen their understanding of the format. And I just think this is it's definitely an investment, And it's complicated because you can't just throw more people at it, really. But at the end of the day, I mean, I spent less than a year doing this, and I think it will benefit people and save people more than a year, in the years to come. So, I don't know. It's worth it as a community to have people who are stubborn enough and have enough stamina to last through these, to cross the desert, basically.
Yeah. How much time did you measure exactly? How much time did it take to develop KB text shape?
I did not. It took about 10 months, but it was also complicated because there were some times where I just felt completely lost, and I was like, I have no energy to work on this, dude. I can't. And so I just took like a month off at some point. Sometimes I took like a week off. But yeah, it was like 10 months of free time. And then, I'm still working on it. So it's pretty much a year since I've started seriously working on this. And I'm drafting up V2. So I think I'm still, in the post-launch kind of maintenance and development kind of phase. So it's not completely done, but it's usable.
So what's on the roadmap? What's on the lookout in the future for you?
Do you mean for this project or just more generally?
Both, but let's start with KB text shape.
Well, I got a lot of the ideas quite recently, so I can actually there is a 3-step plan for text shaping. So the first step is accomplished, which is just like release the version 1.0, which is something that works. Okay. The second step is, good API, but how do you quantify this? Well, it's specifically the way the V1 API works is you give it a buffer of glyphs, and then when it runs out of memory, because there is a substitution rule that says replace this one glyph with like multiple glyphs. So you can run out of memory. And when it does, it asks you to reallocate the same buffer, which is not ideal for many reasons, but like fragmentation is a big one. It's also not as easy to embed into simple allocators. And, if you don't have like a true C library with realloc, it just becomes annoying, because what if you want to shape a large string? Well, you don't really want to realloc like 2K of memory, right? So, so step 2 is improving memory management to work with several discontinuous blocks that you ask incrementally from the user. And that's a big one, and that's mostly done now. And there are also a few other things, but like there are a few edge cases that I did not consider when I wrote the original segmenter, but actually did come up in like 2 hours of it being released by other people. And so I was like, okay, I can't solve this without changing the API, so I'm going to do it for V2, but making sure. So like for V1, I basically tried to reorder the runs so that we would present them to you sequentially, like in order, strictly in order, because I thought, hey, that makes it slightly easier for people to use. Why not? And it turns out, well, to reorder, you need a buffer, and there are some cases in the Unicode algorithms that require infinite memory if you do this. Too bad, so you can't do that.
Okay.
Because a lot of the Unicode algorithms work on regex, actually, regular expressions. And so they will ask you to handle like arbitrary repeats. And a lot of those arbitrary repeats you can handle in fixed memory if you're clever about it. but a couple of those you can't. And so with the strict ordering. And so if I break the strict ordering guarantee, I can make everything work in fixed memory. And, if the user wants to have things in order, they'll just reorder it themselves.
Okay. To finish off the KB text shape.
Yeah, sorry. I completely forgot about step 3. Before we move on. Step 3 is actually, I have some experiments I want to run, but I'm pretty sure it's possible to thread the shaper.
Multi-thread.
Yeah, it's possible to do it threaded. And the way this would work on paper is you pre-process the font, which I already do to some degree, but you do the full structural parse of the font, and you find out glyphs or sequences of glyphs that are guaranteed not to be part of any rule. And that way, you know that you can basically just have a barrier, and one thread can handle the part before, and one thread can handle the part after. And it becomes more complicated on like index scripts, which obviously want things to be clustered in syllables, but I still think there is an experiment to run there that would allow for full multi-threading.
Okay,
so
nice.
That's step 3, but like not soon. That is not planned for this summer.
Okay. Do you know of people who already included KB text shape in their projects?
Yeah, I mean, I talk semi-regularly to some users who want to know how the library works, or who also, most importantly, say, hey, I want to use this, but for the reasons I mentioned before, it's kind of hard to integrate into my project, and it would really be much simpler if you did this instead. And so, when you work on something for a year and you release it, and the first thing you get is, but it doesn't do what I want. It's very frustrating. It's very easy to take it personally, but you can't, because it's not fair. It's not fair to the user. So I try to swallow my pride in these times and write down what they suggest, because usually there is that's where I found the most room for improvement in the API. So like there's a bunch of ways that will read fonts differently also, because since we byte swap everything in place, then you can't just use the font data with STB TrueType anymore, because STB TrueType does not expect it to be byte swapped. Stuff like that. So yeah, these people are great, very useful. I hate it when I receive a message, but it's just, I have to tell myself that this is just the caveman in my head, right? And it's fine.
Yeah. All right. So what is on the lookout for you apart from KB text shape? What's in your near future? Do you have any other projects in mind?
Well, I mean, quite simply, I have a game I want to do. So maybe I'll do that when I'm done with V2. It would be nice. And I think for now I'm trying to make the most use out of my free time and kind of not let the work environment affect me too much. But I feel like this is where we can go kind of like all out on the personal section, and just say that as somebody who really likes working on hard stuff and who likes working on like deep projects, it's been kind of difficult to work in France, really, because I think the culture in France, the work culture, is like very just job, like your job is just something you do to earn money, and you don't really have any personal attachment to it, Or like it's basically just like a fun thing you do sometimes. Like, okay, my colleagues like to program. I mean, obviously some people hate their jobs and I'm very sorry for them. But my colleagues have founded the company, so they like what they do, supposedly. And I mean, they enjoy programming at their level, but there's a constant culture of like, now we don't need to do the hard thing, or like it's not worth it to do the hard thing, or like there's nothing to be gained from, like, why are you trying so hard? Like, are you trying to prove something? Or it's like, no, I just want to work on interesting things. And like, why is it so hard to find people who want to work on ambitious things? I don't get it.
Why do you think that is? You mentioned like culture, but do you think there's a reason for it?
I mean, I could talk about French culture for hours. I don't know. We have kind of a history of strikes, you know. We have kind of a history of hating bosses and CEOs, and kind of hating industry in general, and just being very negative also. But I don't know. I mean, I couldn't tell you when I worked. Worked is a funny name. When I played in tournament on Counter-Strike, I never really played with French people for a long time. And I mostly worked with like Brits and Danish people and Dutch people, because those were the people who were most energetic and most involved. And I don't know, I don't have all of the knowledge necessary to explain why this doesn't happen in France, but it's just there's just kind of a culture of not trying very hard in France. Or if you're going to try, doing things your own way, but in an extreme way that doesn't really make pragmatic sense. So like all of the strategy that I talked about earlier, like how can I make myself useful, kind of becomes moot at that point.
Have you considered the possibility of doing KB text shape not in open source format, but like a paid software? So we would spin up the company and in the RAD Game Tools fashion, license the software and get money for it?
I mean, I did think of adding a renderer on top of it, like a GPU renderer, and licensing that. But then I was like, Slug already exists. So like, what can Slug do? And then I just went and looked at the Slug documentation. I was like, oh, it does kind of everything. Who uses Slug? And then I went and looked at their list of clients, and I was like, oh, everybody uses Slug. Well, that's too bad. I also looked, it's funny, I also looked at font editors.
Yeah.
Because, there is a free font editor called FontForge that is very bad. It is incredibly bad. I've only heard bad things about it. And I was like, okay, so is there a way maybe to make a font editor that's good? And turns out that already exists. I think it's called FontLab, and again, basically everybody uses it. So what might be interesting at some point, or like what would have been interesting in a different reality, is like if I knew personally font designers, maybe we could have worked on like a better font format where the rules weren't so restrained and everything wasn't so hard-coded. But I don't, so it doesn't really make sense for me to work on this alone, right?
Okay. All right. KB text shape is available on GitHub, right? People can find it there. It's a single file library that you can do segmentation and shaping with. And you can use it in C, which means you can use it in any programming language, because any programming language has ability to run C through their mechanisms, respective mechanisms, right? You're working on V2 to update the API to make it stable. And do you have, I don't want to put pressure on the deadline, but do you have any idea on the roadmap? Because this might be interesting to people that listen, that would like to use it. If it's like very soon that the API will change, it might be worthwhile to wait for the change, right?
Yeah, of course. I mean, I want to have it done during this summer. Would be good. I have some time off the coming week, actually, so I'll try to advance as much as I can, but I can't predict.
Yeah, of course.
If I get everything done next week, or like most of the things done next week, then I would expect it to release in the few coming months. But even if you're just interested in half-buzz alternatives, like I have a discussion open on the GitHub page that's like, hey, I'm working on the V2 API right now. Like I'm taking feature suggestions. I'm taking API suggestions. Like, tell me how to make my thing easier to integrate into your project. Please, right? Like it can only help the library.
That's on GitHub.
Yes. Yeah,
Okay.
on the GitHub page.
Okay, GitHub page of KB_text_shape.
Exactly.
Right.
It's one of the first Google results. Hard to miss.
Okay. And you have an awesome blog where you've written up a lot of the things that we've talked about. How can people find the blog?
Well, the blog only has like you're very generous. The blog only has like 3 articles where I'm trying to document what I did and what I understand of text processing. It's at newroadoldway.com. And basically you can find an article that goes in depth into the overview that I gave earlier about text processing. But supposedly you should already know that because you've listened to the podcast.
Yeah. But for the technical write-up, refreshing memory, you can always look there. And where can people follow you and your work?
I am on X, the Everything app. I think that's the main place where I post announcements on the library. I mean, really nowhere else.
Okay.
I try to limit my my social media consumption. I have a Mastodon account that I created and I mostly don't use. Yeah, I'm not the most community-oriented person.
Have you had a lot of social media in the past and now you're limiting it, or you were always limiting it?
Yeah, no, not at all. I mean, even in the old days, and by old days I mean 2009, because that's when I got my PC. Forums were everywhere, and I was not really part of any forum. I was always like very like, I just want a private discussion with people I know personally, and I don't try to go too out there in outreach. Obviously, I made the X account like to publicize the library, so it's not going to be like a full like personal impressions account or anything. It's trying to be like somewhat utilitarian.
You're not on the road to become an influencer, social media influencer.
I mean, you never know. I kind of think, Casey is doing a great job at catching people's attention. Ryan is doing a great job, and they're both saying interesting things. If I have interesting things to say that differ greatly from them, again, I might consider doing that. But I don't really feel like I have much to add right now, so not really, no.
Awesome. So for everyone who is listening, KB text shape, 20,000 lines of code in single file for shaping your text in C, written in C by here Jimmy Lefevre, if I pronounced it properly.
Perfect.
Okay, awesome. Jimmy, thank you so much. This was awesome. 2 hours. Oh, wow. 2 hours of technical discussion. And you have a lot of knowledge. Thank you so much.
Thanks for inviting me to this podcast. I mean, it's it's an incredible opportunity to be on the same podcast as Casey and other incredibly talented people. Like, I mean, Anton, holy crap, right? Like, freaking, it's just such an honor.
I don't know if you were aware, but exactly at the moment where we started this recording, like 2 hours ago, Sean Barrett discussion was posted. So
yeah, I saw your tweet about that. I'm gonna have to go listen to that for sure.
Yeah,
it's incredible. I mean, obviously Sean Barrett. I mean, I have like I was thinking I should do like a Hall of Fame kind of folder for myself at some point. Because I have a screenshot of Casey saying my library is cool, and I have a screenshot of Sean Barrett liking my post that my library is out, and I'm like, oh my god, this is so cool, right? Yeah, it's just unreal. It's unreal.
Awesome. Jimmy, thank you so much.
Thank you.